Hello, this is Jim McKeith, and welcome to this developer skill sprint on adding a JNI call to your Android app. This is going to be focused completely on Android app development, so everything's going to be specific for Android. Now, when you think about development, there's really three different levels of development that you can take advantage of with our tools. The top level is components. This is where you drop a component down that gives you access to a database, or maybe it's a visual component that puts a button on the screen. That's where you have your highest productivity. And then we have the common libraries that you use, and these common libraries work across all the platforms. These are also really highly productive. You can get a lot of code done with very little effort. And because you're able to develop for multiple platforms at once, you get the multiplier that way as well. The bottom level, which is the level that we're talking about today, is the platform APIs. Now, platform APIs give you full access to all the features of the platform. It does require that you use compiler directives if you want to target multiple platforms, because the code is going to be specific to a certain platform. So the code we're going to show you today will be specific for Android. You're probably going to need to convert some of your data types, but it's pretty easy and pretty straightforward, as I'll show you. Now, one thing to note is that most of the platform vendor tools you're going to use out there, or actually a lot of other even third-party tools, only give you access to this level. They only give you access to the platform APIs. So everything that you enjoyed in the common libraries and components is the icing on the cake, is what gives you such great productivity with RAD Studio and Appmethod. So today we're going to look at just the platform APIs level. Keep in mind, this is doing it the hard way, if you will, for some things, although some stuff, it's the only way to get to it, and it's still fairly productive and a good way to get things done. So the agenda, we're going to talk about conditional defines, some useful units you're going to use in this process, and then we're going to look at how to make JNI calls. Now, JNI stands for Java Native Interface. This is how you're going to call Android SDK calls directly through the JNI. And then we're going to also look at how to wrap additional APIs, so that if there's an API that we haven't wrapped for you, you can wrap those. Then we're going to look at how to use a custom set of Java libraries. Note, this is going to work the same with Appmethod or RAD Studio. Appmethod's a subset of RAD Studio, and then it only allows for FileMonkey development, and you can choose for certain platforms. RAD Studio, on the other hand, includes both Delphi, which uses Object Pascal, and C++ Builder. This session is going to use both C++ and Object Pascal in most examples. I'll point you to the resources for these things. Some of it will be only in Object Pascal, but I'll point you to how to do it in C++ as well. So for conditional defines, any of the code you're going to use that's going to be specific to a certain platform, this is what they would look like in C++ and Object Pascal, and there's the DocWiki page to get more information about that. So to make a JNI call, there's some useful units you're going to want to use. So I put these here just so you can come out and grab it. The most useful one I find I'm using a lot is the Java types. That's where JString is, and then Android API helpers, because that's got the JString to string converter, as well as converters going the other direction. Some other useful units are in there. You can find these units and more if you have the source code version. Now, Appmethod doesn't come with source code, but RAD Studio, Delphi, and C++ Builder do come with source code. If you look in those directories there, you'll find the source code to all these units and more. Personally, I use a full text search on these directories. I find the source file that has the code in I'm looking for, and that's how I know what to include in my applications. So check out those directories, and you're going to find out a lot of great information on how to do the stuff we're talking about here. So here's an example of making a JNI call. This is an Object Pascal. I'm going to show you a C++ one next. I've added two units to my uses clause. The first one is the Android API JNI.provider. This is where the class I'm looking for is defined, which is the settings class. This is the class you'd use to modify settings on the Android device. The second one there is the FMX helpers Android, and this gives me the shared activity context, which you need in order to make a lot of calls to other Android classes. So there's two functions here I use that wrap those calls. One's to get the screen off timeout. One's to set the screen off timeout. And you can see them there. I'm using the tjsettings_system.java class.getInt. Now, .java class means I want to access the class itself. So I'm calling a class method or a static method on that class. And the method I'm calling is getInt, which is getInteger. And then I pass in the content resolver and the parameters of the setting I'm looking for. Same thing down below. I use putInt in order to change the value, put a value in there. Here's a JNI call in C++, and this actually comes from the device info mobile code snippet that ships with RAD Studio, Delphi, C++ Builder, and Appmethod. So we have a couple includes up at the top, the helpers and the JNI OS. The JNI OS is the one we need in order to access specific classes we're dealing with, and helpers is the one that we use to make the conversions here. So we get the build version information there, release, etc. So there's an example of calling into the JNI or making a JNI call directly to get access to information that isn't exposed elsewhere. Okay, so the next thing we're going to look at is wrapping new APIs. Now, not all of the APIs are wrapped and included with the FireMonkey framework. So you can wrap these yourself by using the JNI bridge that we include in there. So the secret to this is use the source. Again, if you have an installation that includes source or everything but Appmethod or Pro or better of the Delphi C++ Builder or RAD Studio, then you have access to the source. So if you go into those directories I pointed you to earlier, you can look at the source code for how these are called. And so what you're going to do is you're going to pull up the documentation on the Android class that you want to wrap and look at the information there, and then implement a header wrapper around that allows you to make the calls. Now, you don't have to expose everything in your wrapper, only the calls that you want to make. There are some utilities available that you can use to create these wrappers, and these you point at a jar file and it creates the wrapper for you automatically. In a future version, we'll probably also include a tool as well with RAD Studio or Appmethod. But in the meantime, you can check out those there. And then that last link down there is a collection of pre-wrapped APIs. And so the FMX Express went through and took all of the currently released Android APIs that are available and wrapped all of those. Now, these aren't ready to run. You can't just download these and use them. You're going to have to edit it because of the way the uses clause works and stuff like that. And these are all Object Pascal wrappers. So if you're using C++ Builder, you're going to have to convert these to C++ as well. But you can look at the C++ code and see how this all works as well. Okay, so now let's talk about creating a custom set of Java libraries. This gives you the ability to access third-party Android Java jar libraries. So if you have a jar library that provides some sort of functionality, you can use the process defined there at that link, which is a link to the doc wiki, to create a custom classes dex file. Now, the classes dex file is the Java code that is executed when your application starts up. And so what this Java code does is it loads up the jar files that give your app access to the Android SDK, as well as any special other jar files. And then what it does then launches your native compiled application. Okay, so all of your code that you write is in native code. But if you want to call into a third-party Java jar file, go through that process there. Okay, so I'm going to show you an example, walk you through all the pieces I just talked about, and how to do this. So these are the two folders I told you about. The 14 source RTL Android has all of the Android RTL in Pascal format, and the 14 include Android RTL has all the Android header files in C++ format. So I'm going to go ahead and open this JNI.OS on both of these here. So we'll start with the Pascal one here. And so the general format you're going to see in the Pascal ones is you're going to have the uses clause. JNI bridge is always there and usually Java types. And then any other ones that these types will depend on will also be listed here. So you're going to have a header declaration that's going to list all the types that are in this particular unit. Okay. So we're going to take a look at message. Now message is going to be split into three parts. There's the JMessage class. Okay. So JMessage has the JMessage class, and this is all the class methods that are exposed by JMessage. So if we go into the documentation for the message class, we see that it has a public method called copyFrom. So it's void, so it's a procedure, not a function, and it takes a message called O as the parameter. So if we look here on our JMessage class, these are class methods. So the copyFrom was not a class method. It is a regular method. So here's right here on JMessage. So JMessage has a method called copyFrom that has an O parameter that's a type JMessage. And then we use the C declaration on that. So first part is the class methods, which are here. This is going to have all the class methods. And the GUID here is any GUID. It just has to have a GUID because it is an interface that's attached to this class. And then this GUID here is just another GUID, a random GUID, literally. And then we finally have the TJMessage. That's a class that descends from T Java generic import, and it's a generic class that takes the class method or the class interface and the regular interface, both as parameters. Okay, so these are the class methods, these are the regular methods, and that's it. Okay, so this brings it all together and creates our TJMessage class. All right, let's look at it in C++. So again, we're going to have the imports in here up at the top, the includes, Java Bridge, Java Types, and util. And here is our JMessage class with our class methods. Here is our JMessenger with our regular methods. And we look, there's copyFrom right there. And they're all put together right here. TJMessage, Pascal implementation. This is where they're all put together. So you can look through this, compare it to the documentation in Android documentation, or if you can look at the Java source code itself, that's pretty easy as well. And you can get an idea of how to implement these in a C++ header or Pascal headers. Oh, one last thing at the very bottom here. There's a register types in here in the implementation section. And all this does is it has the fully qualified type, which is based on the name androidapi.jni.os. So whatever unit name you put it in with your class name right there like that. And then in initialization, we call register types. So to take advantage of a third-party jar file, this is the docweek page you're going to need to go through, which I had the short link for you this. And what you're going to do is you're going to create a custom classes.dex file. So this walks you through pointing you to those two directories I was just showing you, where you can get an idea of how to create a native bridge file, which wraps the header for that so that you're able to expose that. So you're going to prefix it with androidapi.jni. And then these are the jar files that you are typically going to include. And so these are the ones that IDE will include for you automatically. You always have to have these two here, the Android support jar file and the FireMonkey jar file. And then what you're going to do is there's two different versions of these. So they're in libandroid debug and libandroid release. And you're going to use the dex utility, dx utility, in order to create one. So you're going to say output classes.dex, and you're going to have the first path will be to Android support. The second path will be to FireMonkey. And then the third path, so you'd have a third parameter here, would be to the other jar file you want to include. So I've created a simple batch file here that I use to rebuild mine. And so the location of the DX bat file is going to be in the platform SDK folders where you've installed the platform SDKs. And it's going to be in the ADT bundle SDK and then the build tools. And so there could be multiple versions of build tools or different versions of build tools installed. So wherever the build tool folders you have installed in, go into that folder there, and there's a dx.bat file that you want to get. So the parameter is --dx output equals classes.dx. So this is the output file we're going to create. And then here's our three parameters. Here's our Android support, our fmx.jar, and then base64 coder. Now base64 coder is a simple little Android jar file that I found that does base64 encoding and decoding because there isn't one built into the standard Java libraries. There is one built into Delphi and C++ Builder in the Indy framework. So you have that available to you there, but this is made for a good demo. So then here we give it the name of the base64 coder jar, which is in the folder where my project is located. So I'm going to run this batch file and it's going to create the classes.dex file. So here we go. I'm in the folder for my custom classes.dex demo here, and I'm just going to run create, and then I have it do a directory to show me that it created the file. There's right there, 623K. So now that I have that in my project, I'm going to go to the project deployment, and I'm going to say all Android configurations. And if I look here, there's two classes dex. I'm just going to uncheck those, and I'm going to add a new one. So I'm going to come find my classes dex I just generated here and add that one here. So there it is. Classes dex, where did it go? There's right there. And I need to change the destination folder to classes. Okay. So now I've included my new classes dex instead of the old classes dex. Now, if I run this without this here, when I make the call to those methods, I'll get an error saying, hey, that class doesn't exist. And so if you get that error, then that means, oh, you gotta come in here and fix your deployment files. If you go back to the page here, it's going to explain a couple other errors you might get. Here's how it explains how to do the deployment, and then troubleshooting different errors you might get. So that's a very useful page for you there. So now I've done this. So now what I have here is this is a wrapper file that I've created around that base64 coder. Okay. So this is the original namespace that was in here. Again, the random GUID. All of these are class methods. There are no instance methods. So you just declare those class methods here. You can look at the source code to figure out how to do that, or like I said, use those utilities. Since there are no instance methods here, we still have to have the instance interface, and then we combine it here into the class, and in here in the register types, we have the register types call. And I'm using the ifdefs for Android, so this only compiles if Android. That way, if I include this in a project and I compile it for iOS, it will still compile correctly, but all this code gets excluded. So here in the main unit, all we have is 3 edit boxes, and then we make the call here to encode. I use the JString to string, which is declared in Android API helpers. And then here's the wrapper I just created. And here's the J64 coder, which we go to the Java class and encode string. And then we have to convert our string to a JString there. That's it. That's all there is to it. And now we can run this on my Nexus 7 and take a look at it on there. Okay, so here's my app running on the Nexus 7. The first text box here, I can type in whatever I want. Hello, world. And then when I tap the encode button, this is going to make the call to the jar file. And here's the base64 encoded version of my text. And then I tap decode, and it decodes that there. So this is making a call to that third-party jar file from my app, and I get the results back, and it all works just perfectly. This will work with a much more complicated third-party jar file as well, but this makes for a nice, simple demo. Realize we moved pretty quick here, but I'm going to make the source code available for you here so you can check this out later. But in summary, we talked about how to use the JNI bridge and create custom classes.dex. Now, this gives you full access to the Android platform. So not only can you take all the great advantage of all the fabulous common libraries and components that we provide, but you can also now access the entirety of the Android platform and call into different APIs, both the ones that are included with Android as well as third-party APIs. Really going to maximize the flexibility and power of your Android app development. So for some more information, the samples, the device info shows you how to make a call with the JNI to call into an Android API directly. There's that link to that DocWiki page that shows you how to go through and create your custom classes.dex. And then right there, the delphi.org/custom-classes-decks is going to be a download link for these slides. And then I'll put the video up here when the video is done as well. And it's going to have the source code of the sample I showed you there of loading the base 64 coder and calling into that. Next time, it's me again. I'm going to talk to you about how to add a voice command to your Google Glass app. This allows you to launch your Google Glass app with a voice command for hands-free operation. This is going to be on Thursday, so in 2 days, at the times you see there. I'm going to encourage you to download the trial. The trial does have full Google Glass support in it, along with the sample I'll be showing you on Thursday, so you can play with it a little bit, and then you'll have questions that you're ready to ask me on Thursday. But now we're going to go to the questions that you have today.
Jeff Overcash, back in the XE5 timeframe, did a translation of the interface for the text-to-speech Java API for Android. And so my blog, I did a blog post back in September that talked about that, and had a little bit of information. And there's the source code project for Delphi is in Code Central, and the link should be showing up there on the screen.
Yep, I see it.
So a pretty simple way of typing into an edit box and typing some text out and having it say it back out. So he went through and he converted the Java code into a Delphi interface unit using, and there's a link here to a tutorial he mentioned that also helped him with the information about how Android text-to-speech worked. And then Regis asked, is it possible to make an Android service?
So we don't have a template for Android services, but Brian Long did a blog post about how to do an Android service, and there's a link there to the FMX Express site's summary of that, how to do that, and then a link to the Brian Long's as well. But so you can do it. It's not very straightforward, but it is possible. That was written in XE5, so you're going to want to look at some of the changes in XE6 because there may have been, I haven't looked into it completely, but there may be some improvements that do make it easier in XE6. For example, the ability to create a custom classes decks is a new feature in XE6. In XE5, you could do it, but it required like a lot more work, and you had to like reverse engineer some things and edit some Java files and etc. It was a lot of work. So XE6 makes that a lot easier because we include those jar files that you need right there.
And Jim, I think you had told me there are a couple different utilities and tools out there that some people have worked on for converting the Java interfaces into Delphi interface units. Am I correct in that?
Yeah. If you go to my blog, delphi.org, the top blog post from today is links to a few of those.
Okay, so here we go. Okay,
so there's a link to the demo I just showed in the slides, and then if you scroll down, it has a link to the different utilities: Java to pass, Java import, and Android to Delphi import.
Okay. So if you have an arbitrary Java interface that you need to convert, these I think are purchasable, right? They're not free.
They are purchasable.
Yep.
Most of them are fairly reasonable. Like I think the Java import was like $80, and I think that's about what the Java to pass one was. The Android to Delphi one is in Bitcoin, so you have to go through Bitcoin conversion. It does also include the ability to bundle it, like I showed you with the classes.dex. So the Java to pass one's free for running against Android API ones, and that's what FMX Express used to create that wrapper of all the Android APIs. And one thing I wasn't clear about in the video, and maybe I can edit this for later, is the correct method for generating that C++ header file is actually you generate the Pascal one, and then the IDE creates during the make process creates the header file for you. So you might be able to circumvent that and just create that header file directly, but the preferred way is to do the Pascal file and then have the C++ header or the compiler make the header file for you.
I see Patrick just asked the question, is this useful if I want to run a barcode scanner in my app?
Yes, it is. So actually, I had toyed with the idea of using the zebra crossing jar file. So for example, you can download the zebra crossing jar file. Zebra crossing is a barcode scanner. You can get it either as a jar file or as an APK. So if you use it as the jar file, then you could embed it in your app using the method I showed you with the custom classes.x, and then wrap the interface for it in the like I showed you with creating a JNI bridge file, and then call that, and then it would actually be completely contained within your APK that you deliver through the App Store. The reason I didn't do that demo is just because the JNI bridge would be a lot more complex, and so I decided to go with a simpler one. And I just assumed it'd be more complex. It might have actually been simpler, but yeah, you could totally do that for that. Now, the start activity for result could also be used to call the zebra crossing barcode scanner and get the result back that way. So there's two different ways you could do it, but yes, you could use it exactly that way.
Yeah. And then Borja was asking, if I need a bridge in C++, do I need to put Delphi classes? Do I need a Delphi compiler? And Stephen answered, you can create C++ examples. See the samples directory link for showing device info. So look at the device info. I forget, it's either in samples, mobile samples, or mobile snippets. That example shows you how to do things in C++ to get to the Java bridge as well.
Yeah.
Let's see. Thomas says, is it correct to say lesson covers accessing Java libraries by wrapping, but you don't need to jump through so many hoops for in any and all application development? Now, we've wrapped a bunch, right? We've wrapped a bunch of the general purpose interfaces that you need to do build an Android app. This is if you have some specialty or some unwrapped Java functionality. Maybe you get a third-party jar file.
Yeah, exactly. This is 90% of your development. You're going to use the components and common libraries that we provide, and you're going to get a lot done really quickly, and it's going to work across Android and iOS both. But occasionally you're going to want to say, hey, how do I change the settings on Android, for example? And there's no equivalent to that on iOS. So you're going to make a JNI call, or you're going to say, hey, how do I call this third-party API or whatever? So this maybe 10, maybe 20% of your app is going to be at this level here. This is going to be specific to Android. But yeah, 90%, 80, 90% of your app's never going to have to touch this because this is the lower level stuff. This is the assembly language of Android, if you will. Just the low level, down to the metal, behind the scenes things that you typically don't need to worry about.
Okay. And Regis was mentioning if something's wrong in your app, or the device that you're trying to run it on, Android device, doesn't know how to deal with, doesn't have the right hardware, you get this kind of blank screen. Saying that you could put up a splash screen. Marco Cantu has a blog that shows you how to do that, but there's still
FMX Express has 3 different ways to do a splash screen on there.
Yeah. So there's still going to be a little bit of delay as the app sits there trying to figure out why it can't do something on a device that doesn't have the right stuff. I always tell people to go and get, let's see, Google Play Syscheck. It's the utility. So Syscheck by Christopher Moeller will run and tell you if you have the right ARM processor on a device and whether it has the Neon instructions. So if it's ARM v7 and Neon instruction is yes when you run Syscheck, then the device you're trying to run on has a very, very, very good chance of running on Android. Also, Regis is saying maybe I misunderstood. He's talking about the little black screen you get at startup time.
Yeah, so I just sent you a link to the FMX Express example on creating a splash screen, and one of those examples there actually will immediately display a splash screen as soon as the app is launched for the second or two before your app finishes becoming available. So with that method, completely eliminate the black screen by displaying a splash screen to your users that then gets displaced by your app when your app starts. So this one is just a line in your manifest. So you can modify your manifest file for Android-specific features. So the question about where you can find more examples of JNI calls on C++ Builder. We don't ship any examples. Basically, what you need to know is if you go look at the header files, you can see how the class is defined. If you're making a class method call, then you use, or a static call, then you use the Java class call from there. Otherwise, you're using it from it's on the class itself when you create an instance of it.
Yeah, there's the device info sample for C++ has an example of using the Java class to go in and get the device information, the operating system version, and so on. So that's one that ships with the product. I mean, ultimately, I always say that the runtime library source code and FireMonkey source code in the product itself, if you look at the C++ header files for iOS, for Android, in this case Android, in the RTL and FireMonkey, you'll see how we have wrapped our R&D team, Android APIs that are in jar files and so on, with C++ code. So this is delphi.org/2014/7, and the one for today, July 8th, has it up here, and down here there's the demo code. Download the slides links on his delphi.org. It's the current article, so if you just go to delphi.org, you'll get to it, or you can use the path. So the demo code is in Object Pascal. I guess I could probably port it to C++, but it's just going to be exactly the same thing as I showed you in the other one. As far as the code, the device info, the code's going to be the same as you saw from there as far as how to make the call to the JNI. But then the way the deployment's done, stuff like that, is going to be exactly the same between Object Pascal and C++. Because it's all language agnostic how you do the deployment. For all the different steps, and here it talks about how to grade the bridge file for either Delphi or the include for C++. Vladislav, you can go into this page again, and I'll put that link in the Q&A. Okay. And
so he asked about how to use kill background processes in C++. First thing you want to do is going to look and see if that's already wrapped. I'll look that real quick and see.
Okay.
So that's part of the activity manager, which I think we do have wrapped. Let me look and see. So we don't have the activity manager wrapped already. So if you go out to the FMX Express GitHub repository I linked to, you can download the files there that you need, and you're just have to edit them. And
so where is it, Jim? Is it?
Go to my blog post there. My blog post that I had.
Here, okay.
And scroll down to the bottom, and right there above the video, see it says GitHub. One more up, right there.
You tried to tell me. There I am. Okay, so there's Object Pascal wrapper.
So you can download the wrapper there for the activity manager, and you're probably gonna have to make sure it's got the right uses clauses and stuff like that. And then once you do that, then you can. Once you're running your project, your C++ project, it'll create a header file for you. And then once you have the header file, then you can make the call to use it.
Oh, here, activity manager. Okay.
So it's probably going to have some uses, like I haven't looked at it in detail, but it might use some things that cause circuit references or something like that. So you're going to have to do a little experimentation to find out what you need to grab. But once you do, then you'll have that. Is it possible to step inside the call inside custom DEX in the IDE debugger? So the DEX code is going to be Java code, so you're not going to be able to step in there, but you can create both a debug and a release version of the class's DEX, and the doc wiki page does walk you through that, how to do that. I didn't do that, I just created a release one, But if you do that, then that gives you debug information while you're running. Question about certification? There's information about our certification program that's available.
Yeah, so there you go. We've got 2 tests, developer level, which is the base level, and then a master developer certification. And those are through test.com. You can purchase keys through our shop site to take the tests, and then if you pass, you get a PDF certification with your name on it that you can download and print out, show to people, give to your boss or employers and so on. Jim, thank you very much. It was a great skill sprint for the Android stuff.